Great. Well, welcome everyone. This presentation should be short and sweet, but it's in everyone's best interest, I think, to kind of hit the basics and really start by telling a little bit about Lattice. Lattice Technology was founded in 1997 in Tokyo, Japan. We have offices both in Tokyo, Nagoya, as well as Westminster, Colorado, where I'm located. And we service really industries across the board. You see them all on the screen here. I'm not going to go into it in too much detail, but we're used by thousands of companies around the world every day to really view 3D content, and we deliver it in an interesting and very efficient manner. So everybody can show you a slide that looks like this. Really, the key takeaway from here is that we have a partnership with Toyota. Toyota owns about 20% of our company. They're a major shareholder, which gives us a lot of stability and a lot of confidence that we'll be here day in, day out, working with all of our customers to provide software that is both unique and very useful in creating and authoring technical communications of any kind. So what do we do? You'll see here on the screen, we partner with some of the largest PLM and CAD vendors in the world, everyone from Siemens through Dassault, PTC, and Autodesk. That means everything from NX through SolidWorks, CATIA, ProE, or Creo, Inventor are all supported within our software. And what do we mean by supported? Well, we can take their data and convert it to our file format natively within our software and reduce the file size to about 1/100th of the regular file size. So you'll see here on the screen, this is actually a 3D model, a full tractor running right within PowerPoint. This model itself, I believe in CAD would be somewhere in the range of a few hundred megabytes with all the parts. This is a full 3D model. This is in our regular display mode. We can switch display modes, or we can move around to a few different types of illustrated type output. We can increase the quality. It's really a universal 3D file format that allows for people to display content on machines that are maybe not super high powered or gifted with the latest and greatest in technology, but also view the entire model, even on a 32-bit machine. So it's a powerful 3D format that is used by quite a few different companies out there, and it is compatible with most major PLM systems. So that's the background for us on what we do, sort of. What we're going to cover today is how we get 3D data into the use more often, to be used more often throughout both design and assembly and production sides of the business, including sales and service. We offer really four main areas that we offer solutions in, which is design review, work instructions, assembly validation, as well as service documents. And I'm going to cover all of these fields today.
Hey, Eric, before we go any farther, let's do a quick poll to get an idea of what job role people have in your organization. So if everyone could just take a moment here to select the role that best describes what you do at your company. So we have half the people showing up as other. Now it's down to 17%. So, okay, leave it open for just a few more seconds, and then I'm going to close this. Okay, very good. So what we, let's see, let me share this. So this is really good because we wanted to talk to manufacturing people today. So that's good. We got a lot of people from design and some in the other category. It looks like I need to expand my choices here. So, all right, Eric, we'll go ahead.
Okay.
I'll hide the poll.
So continuing along, really the first topic I want to cover is design review. And this is really how we kind of introduce the idea of concurrency in our processes. So this applies to design, production, and engineering sides of the business. And we find that design review currently today is often done with CAD, 3D CAD files, which is better than the way it used to be done in the past, but we think that with our file format and the power of our software, there are a lot of advantages. So currently we see a lot of people not able to display full 3D models. So if you're dealing with a vehicle, often you're looking at thousands of parts, and a CAD system, no matter how powerful your computer may be, can often take a period of many minutes, maybe 30 minutes to an hour to open a file, and it may fail after that hour to open the full 3D model. So it makes design review a difficult task to accomplish, and it makes people reluctant to really open up and work with a full 3D model, which we think there are a lot of advantages to doing. So we find that it also is insufficient to be able to do that design review without having to do it's more beneficial to do a design review without having to have a full prototype built. If you can do it with a 3D model phase, you can actually, you'll see here, detect defects in your design process much earlier, which is where we kind of introduced this idea of concurrency. So instead of having to do design, release, prototyping, then finding an issue down the line in the prototype phase where we have to repeat this whole process, moving back to design and starting over again, really increasing our time to market. We find that if we can do it with the whole 3D model, we can do interference checking, we can detect defects earlier and make corrections to those defects and issues far earlier, and really make sure that we front load this whole process of error detection and do it in an efficient manner. Opening up our 3D model can do a full 3D model of a vehicle maybe in a few minutes as compared to an hour, and it's going to open every time. So we find that this really does help speed up the process, and the quality improvements are pretty shocking, actually. So here's some examples of how we implement that. So for our purposes, we have tools that are mentioned here in green. So the green indicates the actual software that we're using. So this is XVL Studio Series and Lattice 3D Reporter. These two tools will allow us to do 3D drawing review, take measurements, do cross sections, annotate those models, and here's an example of the annotation view. There's interference detected. You can feed back to design, do it all in a very efficient manner, and do it maybe from the production side of things. So rather than having to rely on a CAD system to do this, you can use our software to do this 3D drawing review and do it much more efficiently, and feed back to design so they can do the actual error corrections. Another part of it is design validation. With our XVL Studio Pro package, we can do some dynamic interference checking and also report back to design that this model is not going to be able to be assembled or built in the way that they've designed it. And it's a very powerful tool. It also runs, again, much more efficiently in a software like ours. Another tool we have is a difference check option, which is an option for XVL Studio Pro, where you can actually take two models. These are two different XVL files, which are representative of two iterations of our models, and change and compare those in one view. So you'll see the difference between the two models, geometries reported back to you, changes in file metadata as well is all reported back to you in this difference check capability that we offer. So that's it for design review. But here's kind of some results that Toyota saw when they implemented this in Japan. So they found that a full vehicle can be displayed on a 32-bit machine, and those cross-sections, interference, and clearance checking capabilities were very valuable. The results really were that they were able to reduce the time they spent on design review by 1/3, as well as an unexpected result was that they found that they detected twice as many errors in their design as they were finding today. So that whole front-loading idea is that it is actually something that did really pay off. They found that the more efficient the process was to run an interference check, for example, the more likely it was to be run, and the more often they were going to find errors in the design and be able to feed those back at the appropriate time, much earlier than after the prototype phase or during the build. So pretty powerful results. The next topic I wanted to get into was assembly validation. Assembly validation is another concurrent process that we think is really pretty easy to understand. We think that again, with this whole product life cycle that you're seeing on the screen here, design, prototype, evaluation, design, prototype, evaluation, design. Again, all of these repetitive processes can be eliminated if we do the proper amount of investigation into the workability and assembly validity of our models. So we think that if you actually can skip the validation by using less prototypes, you'll find a much more efficient process of being able to front load, again, that whole process and require less repetitive trips back to the design phase of your life cycle. So process planning with the 3D model is a very efficient process in our software, and it improves quality and it reduces the need for rework. And I'll show you what I mean by that. In this example, yes?
Let's throw up this poll question here about if they're using validation software right now. So let me launch this poll. Just a few more seconds on this. It's seeming to be about 50-50. So we'll close this, and there we have it. Pretty split.
Great. Well, I think that's interesting that we find that many of our customers today are not taking full advantage of those validation tools due to the difficult nature of implementing them properly, as well as the speed at which they operate. We find that in our software, if you're able to use those validation tools much more efficiently, and it's just it's going to work, and it's not going to be a big headache, you're often going to use them much more often. Moving on, though, let's talk about how we validate our assemblies in XVL or in our Studio software. In this example, we're doing assembly process planning. How we do that is our software supports multiple BOMs or multiple trees. So in the software, you're going to find that you get initially, when you import a model, a structural tree or an EBOM, if you will, coming over from design. As we know, if you're in the production side, we find that designers often don't understand the complexities of assembly or manufacturing of products as well as they should. Thankfully, in our software, we offer the ability to reorganize that data in a way that makes much more sense for manufacturing. So in this case, you'll see here that this engine is being broken down into sub-assemblies that may come from suppliers, may come from different geographic locations. You can organize that data from design however you like. You can do it by dragging and dropping actual names of files, or you can drag directly from the 3D model. Either way, these two bills of materials are linked, or these two trees are linked within our software, which shows you cross-highlighting, meaning that if you select, let's say, this sub-assembly here, you'll see that it's selected within this structural tree as well, so you can ensure that you're not missing any parts or missing anything important. Once you have those sub-assemblies built and organized how you like them to be in manufacturing, you need to decide on a process. So the same sort of steps can be used to create a process of assembly for those sub-assemblies, which is also linked to the manufacturing tree as well as the structural tree. This is a unique competitive advantage of our software. I think that it really kind of allows for a much more logical workflow and a way that really makes sense for the end user, both visually as well as logically when you look at the data sets themselves. All of these trees themselves are linked to the 3D parts, so however you feel works best for you, you can work within our software to organize that data both visually or by logically by part names, and either or, really. So that's one way of working in validating our assemblies. But another tool we offer is this dynamic interference checking, which is available in XVL Studio Pro, and it can be also used in Reporter. Dynamic interference checking gives you results. You'll see here a highlighting of where this interference is occurring as these parts come together in an animated process. So you're also able to show measurements accounting for clearances that are needed as you assemble your parts. Another feature we offer, which is unique, is a workability validation. We can have the ability to insert human models of different shapes, different sizes, so tall, medium, small humans, and also view what their theoretically what their visibility would be of assembling. So this is an advanced feature that a company like Toyota will use to make sure that tools will fit in and that the human will not suffer too much when they're assembling the product. So a very powerful tool and very high-end feature of our software. Another area where we really kind of shine, and I think this is where we probably do the most businesses in creating work instructions. Now this is something that really is a process we find has not been fully implemented in most companies we work with. So when we look at the way they do things today, it's a very slow, labor-intensive process, starting with creating instructions, possibly doing drawings from a CAD system, or taking images with a photograph of a physical prototype, or creating handwritten work instructions. Handwritten is loosely used. Usually these things are going to be typed up, but they're going to be 2D. They're going to be static sources of content, which require many man-hours, and they're not linked to the CAD in any other way than being sourced from a CAD in many cases. So it's difficult to keep up with design changes. It's difficult to understand when those work instructions need to be changed and which ones need to be changed and updated. This is where we find we can help the most. So where we come in is we can create instructions based upon the CAD data, which can be updated automatically, creating 3D work instructions which don't require any text or very little text, and can be published directly onto a network and shared via HTML or via print. And this content is far more effective and accurate than really what is available in paper or 2D instructions that have been delivered in the past. So it's really easy to understand why these kind of work instructions are better. The process which create them is the part that we find many people struggle with understanding how efficient that actually can be. So I hope to cover a little bit of that here. With our software, we can use a suite of different tools, XVL Studio Standard, our Lattice 3D Reporter tool, as well as Webmaster to do the following. Here you'll see an example of maybe an HTML delivered work instruction, which is a very unique kind of fully featured instruction. We have a 2D looking image here, as well as a 3D animation and a bill of materials delivered. And we can support multiple languages. So once you build this in our software, you're able to publish out and support whatever languages you may need. And the workflow would go as following. You would follow from your XVL Studio tool into Lattice 3D Reporter or XVL Webmaster or iXVL Publisher to deliver to an iPad. You could do any of those types of publishing from the Studio software. So you can automate the creation of the different types of maybe documents with our templated options that are available for the publishing tools that we offer. So there's a lot we can do, and a lot of it's automatic, and it's very, very efficient. So we'd be happy to show you a demonstration of that at any point, but I just kind of wanted to give you the overview of how we do that and how we help. Another big area where we kind of shine is service documentation.
Hey, Eric, let's do one other poll here about multiple languages. So
sure.
We talked about Toyota, talking about Toyota a lot. Of course, Toyota is a worldwide company. Multiple language support is really important. So if you can take a moment here, okay. just a couple more seconds, and I'll share this. So overwhelmingly, yes, multiple languages is an issue.
Great. Great. Yeah, we find that to be very, very universal. That you know, go ahead.
And one other thing I wanted to tell people, I failed to mention at the beginning. If you have questions, please submit those in the question box, and we'll get to those at the end of the webinar. So please, if you have any, just go ahead and submit those. Go ahead, Eric.
So the last really area I wanted to cover is service documents and how we create those. So what we're talking about here, parts catalogs, you know, manuals, or handbooks that you may be creating. Often we find that these are, again, a very labor-intensive process, often overlooked till the very end of our product life cycle. So what we need to do is kind of show you how we can help and, you know, take this antiquated process of, you know, doing drawings via, you know, export from the CAD, or, you know, using images, and then having some sort of illustrators or you know, people that are working in this area publish these documents, which are often, by the time they're finished, irrelevant or inaccurate. We find that there's a much better way of doing them. We offer a automated process which will allow you to use the 3D CAD data from design and automatically create illustrations or publish 3D parts catalogs, not requiring any prototype, not requiring a real product. It offers a very standardized output, and this process, like again, can be automated. So the way we accomplish that is we can use tools like XVL Webmaster or Lattice 3D Reporter, which will use a template option to publish again, parts catalog, 3D parts catalogs that are include bills of materials that are all linked to 3D views as well as 2D illustrations. These are automatically created from the same workflow that you're using to create all of the other type of documentation or instructions that we've kind of covered today. So all one workflow really will allow you to create all of these different types of documentation or communications that we've kind of covered today. You can also use our illustration option directly from our studio tool to create illustrations that are both you know, able to, you know, show a traditional 2D look or even the 3D look with any kind of cross sections and drawings, as well as balloons highlighting, you know, the bill of material listing. So if you want to create 2D illustrations or 3D interactive parts catalogs, both are able to be accomplished automatically and efficiently with our tools. And to kind of highlight really what the power of XVL is, I wanted to kind of show you how far Toyota has taken this XVL concept. We call it the CAD plus one concept here. Really, it's taking that CAD, traditional CAD workflow and moving it into XVL to accomplish really all of these different types of output and communications that you see on the screen. So it's a very, very powerful tool that's being implemented in a whole lot of different ways within Toyota and other companies. So I kind of want to end with that. I just wanted to keep this webinar very short and sweet and kind of give you an idea as to what there is available out there in terms of our tools and how they can be implemented within the company. And I appreciate everyone's time today, and that's all we have. Any questions?
So, yeah, so thanks, Eric. And again, submit any questions that you have, and if you could do this final poll question of what CAD system you're using. And again, the questions are open. Anybody who wants to submit something. Today or tomorrow, we will be sending a follow-up email, and with that we'll include a recently completed case study for a company that uses Lattice technology for collaboration in their company and how they reduce time to market by implementing company-wide collaboration. And so again, just to emphasize, the theme today was about concurrency. So with Lattice solutions, moving your CAD files into XVL, and we can bring together CAD system, multiple CAD formats into one instance, and people can begin working on downstream processes from engineering while products have not been fully baked yet and haven't been released to production. So here's the results of the CAD systems of what people are using. So we kind of expected a lot of our customers do use CATIA, very large, complex assemblies, gigabyte-sized models that we're able to accommodate very well. And it doesn't look like we have any questions, Eric. I think you must have done a really good job of making things super clear for people. So with that, we're going to wrap up right on time here. So I'd like to thank you for your time, and please look for that email. Thanks for your time.